Good morning, everyone. First and foremost, I would like to thank you very much for the opportunity to present my paper entitled Societal Biases Reinforcement Through Machine Learning, a Credit Scoring Perspective. The objective of this paper is to demonstrate that social biases are naturally and mechanically captured in the data used for credit scoring, and in turn, in the results obtained from the model. Algorithms, through training dataset, have a tendency to reinforce social biases. I'm happy to announce that this paper has now been published in AI and Ethics by Springer. The problematic we're trying to address is, does machine learning and AI ensure that social biases thrive? By thrive, we mean that these are reverberated in the subsequent data set and are never corrected. In the first step, we will present some evidence of social and societal biases as reported by governments or NGOs. Here, an important point is, if social bias is something such as a discrimination between gender or ethnic group, this one becomes societal the moment it becomes the norm. After the presentation of some evidence, we will present the data sets, the methodology, and then we will discuss the results. We therefore now present societal biases evidence. In this slide, I present a picture I took from a publication released in 2018 by the Office of National Statistics in the UK, and it is noteworthy to mention that we can find similar graphs from publication released by ONGs or governments in countries where gender or ethnic group statistics are permitted. What we observed here is there is clearly a gap in terms of income between men and women, except in one category here. And there is also a difference in terms of income between the various ethnic groups. In some countries, these differences between ethnic groups might even be wider. I observed that in some of the publication I read and some of the other documents. These are reported in the paper. We will now present two data sets used in our analysis. The first one will be referred to as the gender set, and we will try to analyze the impact of being a man or a woman on your likelihood to obtain a loan. And in the second one, we will address the problem from an ethnic point of view. In this first data set, the gender set, we present here some statistics related to the fields contained in the data set. We obviously have the gender. We know whether the people are married or not, their level of education, whether they have dependents or not, and the number of them. where they live, their income, if they are self-employed, and obviously if their loan request has been approved or denied. Besides, we have some more features related to some feature engineering. We will try, if possible, to use these to improve some of the results. The second dataset, referred to as the ethnicity dataset, provides information about, obviously, the ethnic group of the customers, the number of credit cards they have, their credit limit, their level of income, their age, level of education, their gender as well, and their current balance, among other things. We also see here the gender of the customer, but in order to make sure that our analysis was robust, we split it and wanted to use like two different data sets to address the same question of social biases from two perspectives, the gender and the ethnic group, and ensure the robustness of our analysis. In this slide, we represent the histograms characterizing the income of each gender contained in the gender dataset. We see that women are earning more than men in the dataset used. In this second dataset, we represented the income per ethnic group, and we see that in the dataset used, the incomes are homogeneous and as such are not necessarily representative of what has been reported by government statistics or NGOs. In other words, the dataset here is not socially biased. Here, for only analytical purposes, we combine the Asian and the African American ethnic groups' income and represented them versus Caucasians. Obviously, as previously, the income level were homogeneous, so we don't see significant differences between these two categories. We created these two categories more for the purpose of the modeling to see if we could have very different results, and once again to ensure the robustness of our approach. In this slide, we represent the income of the various ethnic groups, considering that these have been reduced by a factor of 20% for the African American and 10% for the Asian, to better reflect what has been reported by NGOs and national statistics on the first hand, and also to see that if an ethnic group in a data set has, in average, a lower income than another, then how this would impact their access to loans, and in other words, their credit score. We will now present the methodologies used in this paper. In this paper, in the first step, we ensure that the data sets are actually suitable for scoring purposes, because even if we can demonstrate that they are biased, if they are not used for credit scoring, then for the purpose of this analysis, they are meaningless. In the second step, once we have proved, or more, we have validated the dataset, we will try to predict either the gender or the ethnic group of the customers considering this credit scoring dataset. And then we will present the results. Two machine learning approaches have been implemented for the purpose of this paper. A first one, the main one, a random forest, either for classification or regression purposes. Simple to implement, fairly interpretable, and prevents overfitting. And for comparison purposes, a supervector machine. When the datasets were unbalanced, it means that, for example, when the number of men was much higher than the number of women, or when an ethnic category has a lower number of individuals than another, we implemented a smooth approach, a synthetic minority oversampling technique, that allows creating new data points presenting the same characteristics as the one contained in the class to be augmented, and allowing a larger data set and improving the reliability of the results obtained with the machine learning strategy mentioned previously. We will now present the results obtained. From a credit scoring point of view, we see that the ethnicity set, either considering the original one or the version with only two categories, is acceptable as the mean square errors were pretty low. Here, obviously, the indicator was a mean square error because the response variable was continuous. We were talking about a credit scoring. Now, regarding the gender set, either using the random forest or the supervector machine, initially on the original dataset, we saw that the results were not that good, and therefore the dataset, the original dataset, was not validated for loan prediction purposes. Here, the problem was a problem of classification, as the response variable was discrete, and we used an F1 score. After engineering some feature, the results were still not that good. It's only when we implemented a smooth approach to rebalance the categories that we obtained acceptable results and that we validated the dataset for credit scoring purposes. We then presented the variable importance charts of both datasets. And it's interesting to note that the most important factors driving either credit scoring or loan approval are related to customers' income. We see their credit limit, their balance, their income for the first one are the most important, and the applicant income, the credit score, the loan amount, and the co-applicant income, as well as the property area, are the most important for the gender set. So we see where we're going here. If there is some income discrimination between genders or ethnic group, it would be naturally captured in the data and reflected in the scoring results. And that's what we observed. Considering the ethnicity set, we can see that the F1 score obtained, as now we have a classification problem, was already pretty high considering the original data set, showing that biases or somehow discrimination between ethnic groups were already captured in the data set, or not necessarily captured as such, but the differences between the ethnic groups, not necessarily represented by income in that case, were already captured in the data. It means that, for example, like if some ethnic group has a lower number of children than another, then that would characterize, with respect to the data set, this ethnic group. So we capture some information. When we modify the data set, having differences in terms of, or larger differences in terms of income, and we implemented the SMOTE, then the result is quite impressive, validating the fact that I'm able to predict the ethnic group of a customer based on the credit scoring data provided. So once again, it was a very good result considering the original data having homogeneous data set with very similar income between the ethnic groups. It's even more impressive in a case where the income between the ethnic group are different. Results are fairly similar considering the gender set, where the F1 score, once we implemented the SMOTE approach, are very high, allowing us to conclude that we are able to predict the gender of a customer using, once again, credit scoring dataset. In terms of conclusions, in conclusion to the problematic and to the question, does machine learning and AI ensure that social biases thrive? The unfortunate answer is yes, because we use some data to score customers, to approve loans, and then the results are included in the historical data and reused for further credit scoring or loan approval. So it doesn't correct itself. Then it's not easy to tackle it because bank profit generating paradigm and prudential rules are not necessarily helpful in that sense. Besides, when you start like unbiasing on one side, unfortunately, it means that you're probably biasing on another one. And that's not a better solution. So I was a bit frustrated with those results because though I think I pointed out a very serious problem, I felt like I didn't have like appropriate answer or solutions to tackle the issue. That's why I'm going to continue my research and try to, in a subsequent paper, provide some solutions. Let's see now the bibliography. Here I present the bibliography that might be of interest. I'll also be happy to answer any comment or question, and you can contact me either by LinkedIn or by email. Note that the datasets are publicly available, and if you download the paper, which is also publicly available, you'll find the link, the direct links to or towards these datasets. Thank you very much for your attention.